All right. Hello, everyone, and welcome. My name is Tiffany Hall, and I am an alumni of TripleTen Software Engineering Program. I'm a full stack software engineer. And tonight, I'm very excited because I get to also host the October Data Science Data Jam for TripleTen. So we have students with us tonight that have been working on a project, and we're going to see all about it. So if you're not familiar with what a data jam is, let's take a couple of moments and just do a quick review. So a data jam is where we have these very friendly competitions here at TripleTen, which gives our students a chance to really put into practice what they're learning in all of our different programs. So this takes place during their normal coursework, and they're super short competitions where the students get together, we give them a prompt, and they jam out a bunch of work, right? So the jamming and the jam, there's no actual jelly or jam. It's just a figure of speech. Okay, so then our data jam consists of two parts. So we have the prompt, which is where our teams are going to take that prompt and they're going to work with the data, build up models, and they're going to go through all of the coursework that they've been learning, but in a real life situation. And then the second part is what we get to do tonight, which is the presentation. So our team, all of our students were divided last week into teams, and they were challenged to work together and explore natural language processing models using Hugging Face transformers. And I'm sure if you are at all interested in AI or have an internet connection, I'm sure you've seen Hugging Face everywhere. So I am super excited to see our students using this technology. So they have been asked to perform sentiment analysis, which is where they're going to take different text pieces and figure out whether the text sounds positive or negative or neutral, and all just using these different models. So, going to be very exciting to see what data they've got for us. The teams only had 5 days to work on their project. So again, very short time frame. Tonight, they're going to show them all off, and then the judges are going to review them next week. All of our results will be posted on the hub and on October 31st or on our socials if you are not a student of ours just yet. Speaking of, if you are a student of ours, you can vote for your favorite team tonight in the hub. There will be a poll in the channels for you to vote on your favorite team. But if you're not a team, sorry, if you're not a student just yet, then you can vote in our live chat here on this YouTube stream, or if you're watching it later, you can reply in the comments and just list your favorite team. And then that team will get a special award. And I will do my best to make sure Sharkbait, my cat, does not put any of his like toys in it or cheese, but I make no promises. So our first team of the evening is going to be the Transformers. And so the Transformers is a team of Gilles Fadu, Raphael Liu, and Jimmy Kester. All right, Transformers, take it away.
Sure. Let's see. Okay. There we
So
go.
every day, yes, I can see it. Thank you. Every day, millions of people share their thoughts and emotions online, in tweets, posts, and comments. But can a computer actually understand how someone feels just by reading their words? That's what our project set to explore through sentiment analysis using Hugging Face Transformers by our team, the Transformers. Before we go deep into detail, let me introduce my team. Next. So it's first myself, I'm TripleTen DS graduate, Jill Faldu, followed by another TripleTen DS student, Rafael Lu, and then lastly, it's TripleTen DS student, Jimmy Koester. Before going into detail, let me go to project overview. Here is our quick overview of our project. Our goal was to perform sentiment analysis using Hugging Face Transformers. We used Roberta and Distilbert to classify emotions in text. The process included cleaning real-world data like usernames, URLs, and emojis, handling multi-emotion cases, and comparing both models. In the end, we created a reproducible Jupyter notebook showing sentiment predictions, model comparisons, and emotions patterns in text. Next. Okay, so now after defining our goal, let me go over our quick questions. Can we automatically detect emotion in text? Next would be which models performs best. Was it Roberta or Distilbert? How do multi-level and single label approaches compare? Does Roberta really outperform Distilbert in understanding sentiment? What insights can we uncover from real world text? Also, are some emotions more common than others? And finally, how confident is the model in predicting each emotions? So before going more into detail, let's go at our data set. So our data set came from the Smile Twitter emotion dataset on Kaggle. It includes around 3,000 tweets, especially 3085 entries. Each record has an ID, the raw text, tweet text, and sentiment labels that can be single or multi-label. That possible emotions include happy, sad, angry, disgust, surprise, no code, and not relevant. Now my coworker Rafael will take over it.
Sure. So when we initially explored the data, the first step we took was, of course, to remove the duplicate entries. And then because these were tweets, um, you'll see in each tweet like the username, in case the tweet has a link with a link to a website, those could potentially confuse the Hugging Face transformer. So we standardized the tweets by replacing all usernames with @user and replacing web links with HTTP. We also removed emojis and special characters. Um, and in some cases, with our original data set, we had a tweet that was classified with two emotions. So we used multi-labeling to separate the two emotions from a single tweet. For example, happy surprise. So we would create a separate entry for the tweet and then a label happy, the same another record with the tweet and then a label of surprise. And then to train our model, we split all the data into an 80-20 train test ratio. And then we didn't include a validation step because these are integral to the transformers. So yeah, just a little bit more of what I said. We converted each of the labels into tokens to be able to feed into the transformer. We use the multi-label binarizer to handle tweets with multiple emotion labeling. And yeah, we compared, like Jill said earlier, we compared the Roberta and Distilbert transformers. So here's kind of a workflow of what we did. We first decided to work with the Distilbert transformer. So we first passed the data set to Distilbert as is. However, this yielded limited information because the way Distilbert is built is that Distilbert only recognizes positive, neutral, or negative emotions. However, the data set that we found had multiple different emotions. So for example, first time we trained the transformer, it would try to plot surprise onto negative, which doesn't really give us any useful information. So instead, we retrained the Distilbert model to recognize multiple labels for all the different emotions that were featured in our data set. And we did the same thing for Roberta. So because we already knew that Roberta itself also originally only recognizes the three positive, negative, neutral emotion, we skipped the first step and directly retrained Roberta to recognize multiple emotions. So this is a example of the first pass that we did by feeding the different data set to recognize different emotions to Roberta. And the two had pretty comparable results. If you round it, there's pretty much no difference in the performance. Oh, and to measure model performance, we use the loss function BCE loss logits, which was for a classification task. So in the end, just because it was a bit easier to work with, or just so the end, we decided to use the Roberta transformer for further training. So in order to fine-tune Roberta, we found another data set online. This one was sourced from the career contextualized effect representations from emotion recognition research paper. They had a data set available with 16,000 tweets with similar emotions to our original data set. For example, they had joy, we just recoded as happy. They had sadness, we recoded it as sad, so it matched our original data set, and we fit that into Roberta. We trained it for 4 epochs. Um, in the end, we got down our, at the last epoch, we actually got our loss function down to 0.4. But as you see here with the validation loss, it was actually when we validated with our separate test set, it's likely that it was overfitting. So we decided to go back to step 2 with still a pretty good loss function in the training step, but still a good a fairly robust validation loss, which means that our model is likely not overfitting or just trying to memorize the data we trained it on. So I'm hand it off to our team member, Jimmy.
All right, so we start by visualizing how Roberta sentiment models have before applying them to new data. On the left, we have unlabeled frequency versus mild confidence. This shows how often each emotion appeared and how confident the model was in predicting it. We noticed that common emotion like joy and neutral had higher confidence, while rare emotions like fear or surprise show lower confidence and more variability. On the right, the graph shows mild predictions per sentiment, which breaks down how confident the model was across all emotion classes. This helped us see where Roberta clearly distinguishes emotions and where overlap occurs, for example, between sadness and anger. Together, these visualizations gave us a baseline understanding of how well the model interprets emotional tone before testing it on creative data. On the next slide, we had song lyrics sentiment analysis. We wanted to test how flexible Roberta is. Like could a model trained on short tweets handle something much more creative and expressive like song lyrics? For this part, each lyric online was analyzed by 2 versions of Roberta. The multi-label model, which can capture multiple emotions per lyric, useful for songs with mixed feelings. Then we have the single label model, which predicts just one dominant emotion. We compared emotion frequencies across different artists and genres. Pop lyrics learn towards happy and neutral tones, while alternative or indie songs show higher levels of sadness and fear. Overall, we found that Roberta could generalize surprisingly well to this new kind of text, though longer poetic languages does not make the model's confidence less stable. Um, on the next slide, about how about headlines? That challenge with longer text led us to ask, what about something shorter, closer to what the model was originally trained on? So we tried running Roberta on a new real news headline from the New York Times. Part of the Argo was shut down with no clear end poses new economic threat. The multi-label mile spread is predictions across the emotions, mainly anger at 0.29 and no code neutral at about 0.24. The single label model, on the other hand, produced very strong probabilities for anger and disgust, both above 0.9 as the probability. This shows that when given concise, emotional, charged text like a headline, Roberta performs much more decisive and confidently. In short, the model handles short, tweet-like language far better than long, artistic text, but it still captures the intended tone quite accurately. Um, on the next slide for future directions, looking ahead, there are several ways to build on these results. First, we can fine-tune the model on larger and more diverse data set to boost accuracy and generalization. Second, we extend sentiment analysis to a new text forms, such as poetry, reviews, or news, to explore how emotional tone shifts across domains. Third, we would like to experiment with hybrid or assembled models that combine this bird speeds with Roberta's nuance. And finally, this work has practical impact. Emotional detection can support social media monitoring, mental health and, analytics, and creative applications like music or literature analysis. And on the next slide, on our conclusion, in summary, our project explored how transformer-based NLP models, specifically this Dilbert and Twitter Roberta, classify emotions across very different types of text, from tweets to song lyrics and headlines. We found that Roberta captured nuanced emotions and generalized well across text types. Um, Bird was faster but less sensitive to overlapping emotions. Multi-label modeling reflected complex emotional tones more effectively. Our visualization revealed both strengths and limitations and mild confidence, showing that while these models are powerful, they still struggle with ambiguity and rare emotions. Overall, we show that MLP can move beyond simple classification and start to interpret the emotional depth of human language, whether in tweets, headlines, or song lyrics. And the end.
All right, that was fantastic. Really interesting, kind of working with the tweets, and then I love how you guys went to the song lyrics next. I think that was a really interesting choice. But let's talk first about how was it for you guys as a group to work with the Hugging Face Transformers? Just kind of overall, would you recommend? Would you not recommend? What do you think?
I would recommend it. There's if you look onto so there's like a whole community that boosts Hugging Face. If you go onto their website, there's an entire hub, multiple universities, private individuals. They all try to post their different models and different use cases, and the documentation between each transformer is can vary. For example, the documentation for Distilbert was a little bit sparse, so it took us a little bit to figure out how to use it effectively. However, like Roberta, for example, had very robust documentation and instructions about how to use the transformer. So it's just a very wide open field, and there's so many potential applications, and there's like multiple communities, and there's an entire community out there exploring how these transformers could work.
Fantastic. And Jill, how was I know you wanted to do this one, especially because you love doing all of these jams and like getting the different experience. This one is super different than ones we've done in the past because it's using again a newer technology that's only been around for a little while. So how was it applying what you've been learning in the program to this kind of newer technology?
It was different. I had to like really understand it, what it means. And then Rafael, he was really good at it. He really supported me, and then Jimmy too. Honestly, I was lost, and on this time I didn't had that much time. I would say I didn't able to put like that much effort as I did like last core jam. So they were the really I would say the driving force.
Love that. And then
Yes.
Jimmy, like, tell me about the choice to go from tweets to song lyrics, because I think that's like a killer way to really push it to the limits, right? There's so much idiomatic expression, so much imagery. So tell me about that as a what was the talk about with the team?
Well, I can't take any of the credit. That was Raphael's idea, and we like once he brought that idea, we immediately swooped in and jumped on that. It's like, oh, this is a great idea. I would never thought of it without him, to be honest. So
Yes.
I can't steal that credit from
Aw.
him.
No, no, I think it's a team effort, right? Because that's the thing. When one thing that I think is always true is like teams that are really able to vibe together and work well are able to come up with these inspired ideas. And so it seems
Mhm.
like you guys really found a flow working with each other.
Right? Yeah, we did. Yeah.
Yes, Gio.
I would like to add that, like when I was working on Distilbert, so we decided that they will work on Robert, I'll work on Distilbert, and then I got stuck. And then they like supported me. Of we were trying to find kind of how to fix the error, and that was like a really good part where we came together. And honestly, like this time we all were like Jimmy. He works like so many hours. If I'm not like wrong, he works like 12 hours or something. And
This week I
Raffle is
did. Yeah.
busy. Raffle is busy. I'm busy. We all are like in different time zones. And this was the core jam we were honestly we met like last Sunday, and then we didn't meet. So coming everything together just by text, it
Yeah.
was like pretty nice, and it came out really good. I didn't expect, but they were really supportive, I would
No, that's
say.
really great to see how much you guys were able to accomplish just asynchronously. The
Yes.
power of communication there is really strong, obviously.
Mm-hmm.
Kudos to you guys. All right. Well, that was our first team of the evening, the Transformers. And speaking of people who are always working, Jill joining us from her break on her job. We're going to say goodbye to her. She is going to go back to
Bye.
work. Bye, Jill. And we are going to go ahead and say thank yous for the rest of the Transformers. And that team is Jill Fadu, Raphael Liu, and Jimmy Kester. All right, we are going to go on to our second and last team of the evening, and that's the data builders. And just like we are hearing from our other teams, they are also all out working and not able to attend live. So they pre-recorded their videos, and I'm going to go ahead and show those now. So let's all take a moment and relive the horror that was teaching remotely, where your teacher has to try to share the screen. All right, let's see. Sharing, desktop, yes. Sharing sound. Okay, here we go. Oh, knitting. That's definitely not where we need to be. I mean, I'm a big fan of knitting, but that's not where we need to be. All right, here we go. So this team, the data builders, is Victor Kuflinski and Preeti Sagar, also who have done a number of the code jams. And so I'm very excited to see what they were able to come up with. I will go ahead and hit play, and I'm going to turn off my video and all of that, and so that way it doesn't block the video. Okay, here we go.
There's no sound.
I will tell you today about the. Hey everyone, I will tell you today about the models we choose for this project. So we tested two pre-trained transformer models from the Hugging Faces model hub. The first one is this Tilburg. It's a smaller, faster model with 66 million parameters. That was originally trained on movie reviews and making it efficient for general sentiment analysis, binary, positive and negative classification. And Twitter Roberta is a larger model with 125 parameters that was specifically trained on 58 million tweets and making it an expert at understanding social media language, including slang, emojis, and informal text. Twitter Roberta provides three-class classification. It's positive, natural, and negative, which gives us more nuanced insights into visitor sentiment. Our evaluation showed that both models performed well, but Twitter Roberta clearly outperformed Distilbert on some museum tweets. So Distilbert achieved 75 to 80% accuracy, which is respectable for a general purpose model, and while Twitter Roberta achieved 78 to 85% accuracy, and thanks to its specialized training on social media data. So the confidence scores from Twitter Roberta average over 85%, indicating the model is very certain about its predictions, and which is crucial for automated decision making. And based on these results, we actually recommended deploying Twitter Roberta for production use because it's specifically optimized for the type of informal conversational language found in tweets. So the most important lesson from this project is that modern transformer models significantly outperform traditional machine learning approaches for social media sentiment analysis. Unlike traditional methods that require manual feature engineering like TF-IDF vectorization, transformers understand context and word relationships automatically, making them much more accurate at detecting nouns, sarcasm, and complex language patterns. So all these models are production ready right out of the box with no training required, and very high confidence scores allows us to automate most decisions while routing only one uncertain cases to human review. So the business impact is substantial, and the museums can now automatically monitor sentiment across thousands of daily social media mentions, identify testimonials for marketing, detect complaints for rapid response, and track visitor satisfaction trends over time and all at scale. In conclusion, we successfully implemented and evaluated Hugging Face transformers for museum sentiment analysis, demonstrating the power of pre-trained models in real-world applications. The Twitter Roberta achieved our best performance at 78 to 85% accuracy, proving that domain-specific models trained on social media data significantly outperform general-purpose models. So these context-aware transformers eliminate the need for manual feature engineering and can understand nouns language patterns that traditional machine learning approaches can miss. The system is production ready and can process thousands of tweets per day and enabling museums to automatically monitor visitor sentiment and identify marketing opportunities and respond quickly to complaints. Thank you for your attention.
Okay, so as we saw with that team as well, they also really liked the team. They were Team Roberta, as they said. So really exciting information. I am sorry that they couldn't be here. It seems like they had a lot of information though, and also were able to get through much of the prompts. So thank you guys so much, Victor and Preeti, for sending in your recordings. All right, friends, that is going to be the data builders. And again, that is Victor Klifinski and Preeti Sagar. And then that is pretty much going to wrap it up for us tonight. So for all of us here at TripleTen, thank you so much for joining our October Data Science Code Jam. This has always been one of the most interesting because all of the students take the most like mundane black and white things and have to make them super interesting and explain them to people like me who just do code. So I very much appreciate your hard work and effort. If you are a student of ours, please pay attention to the hub for the poll where you can vote for your favorite team for our audience award winner. If you're not a student of ours just yet, please vote in the live chat, or if you're watching this on replay later, vote in the comments by listing the team names below. Again, our team names are the Transformers, that was first, and the Data Builders, that was second. All right. And then, as we've talked about so much, thank you for also working well with all of your teams. I, of course, couldn't do this without my own team, which is Daniel, Camilla, Elisa, Elena, Olivia, Dennis, Anastasia, and of course, my cat Sharkbait. And then if you need to find me, you can find me at Tiffany Codes on Instagram or tiffanycodes.com online. And if you need to find Sharkbait, you can find him in front of his food bowl waiting for the timer to go off. All right. Thank you all so much and have a great night.